What's up guys, welcome back to the next video in learning awesome and discrete mathematics. My name is QTS Dani and you guys watching my channel Coriowood. Okay, so in this video we're gonna discuss the truth tables. And what is truth tables? Truth tables can be used to show the possible truth values of compound statements. A truth tables has one column for each input variables. So the example is P and Q that we've seen in the previous videos. So this is a truth table, and if you guys look in here, that the first one is a P, then we got a Q, and then we got a P and Q. So this one's here true, T for true, true, true and false, false and true, and false and false. So the end statement, if you guys remember, the first is true and true becomes true, true and false becomes false, true and false and true becomes false, and false becomes false. Because if, as I said to you guys, there is a difference between and or. So with the or, if one side is true, then it becomes true, but the end is quite opposite to the or. So you guys, if one side is if both sides, it has to be true in order for this one to be true. Otherwise, if one side, if you notice here, this side is false, then they are not matching. So if it's false, then it becomes a false. So that's the end. A truth table sets out the functional values of logical expressions on each of their functional arguments. That is, for each combination of values taken by their logical variables. Truth tables can also be used to show whether propositional expression is true for all legitimate input values that is logically valid. We continue our discussion on the truth table logic. Truth tables used to display truth values of compound statements. We use a two-valued logic. Every statement is either true or false. This is called the law of excluded middle. So the law of excluded middle states that our every statement is either a true, which is 1 in computer science, and false, which is 0. So you guys think of this as a true, as a positive, or negative. So either our every statement is either true or false. This is called the law of excluded middle. So we're looking here for our first table. The first one is the P is true and Q is true, and we're looking for P and Q is true. So if you guys look in here, we have a true and true, and we have a false and false. And if you look in here, that's the first one is true and true and becomes a true and false. Then we test for it becomes a false and true and false and false. And because the and behaves true and true and true, and true and false becomes false, and false and true becomes false, and false becomes false. Then we coming for the next one is or. Then we have P, Q, and we have a P or Q. The truth table for the or is true and true becomes a true, true and false becomes a true, false and true becomes true, and false becomes false. If you guys notice here, the difference between the or and the n, if you look in here at the first one is a true and true becomes true, that's fine. But here, if you notice here that true and false becomes false, here true and false becomes true or false. So we look in this one as a true or false. So this guy here is or, and this guy here is and. So that's and true and true becomes a true, and true and false becomes a true. Why? Because that's how the or behaves. So the or is quite opposite to the and. If 99% of this one, think of this one as if the 90% of this one is, say, true, and even 1% of this one or 10% of this one is false, it becomes false. So here it has to be 100% true for our truth tables to become true. So here is true becomes true. Here is we have a false, it becomes false. In this side, the first one is the P is false and the Q is true, it becomes false. Here the false and false becomes false. And if you look in here, it's quite the opposite. So here we have 1T and 3F. Here we have a 3T and 1F. So that's how the AND and OR behaves. And looking here for P or implication, so we have a true and true. P implies Q is true, true and false. P implies Q is false. And if you're looking here, P is false and Q is true, and P implies Q is true. And if you're looking here, false and false is true. Think of this one is if you guys go and want to reward someone, and you say if you get A, say if you go to say if you get an A in your school, then I'll give you, say, money, for example. I reward you. I'll reward you, or if you guys say I'll reward you, I will give you money if you get, say, A in your class. So has to be, this has to be like if you guys say I'm gonna give you reward, so I'm gonna clear that one. I'm gonna clear everything here. So the statement becomes true if I keep my promise, and it becomes a false if I don't keep my promise. So in the first one, we see that I'll give you, if you get A, then I'll give you $1. So if you get it, it means that the first one you're getting A, and I'll keep my promise, I'll give you $1. It becomes a true. And if you get an A, then I don't keep my promise, and you get an F. It becomes this one becomes a false. All right. So here you didn't get an A, and since you didn't get an A, then I don't have to keep my promise. Because I don't have to give you money. So since I don't have to give you money, then the condition becomes true, because here you first the condition was that between me and you, because you are supposed to get an A, then I'll give you money, because then if you get an A, then I don't have to give you money. So from my side it's all okay, because you didn't get an A in your class. So here I don't have to give you money, and the condition becomes true here. And the last one, you didn't get a A in your class, and so I don't have to give you money. So I don't have to give you anything. Even if I give you money, or in this case I give you money here, or I don't give you money, then the situation becomes true, because I don't have to keep my promise. So keep in mind this one. So false and false becomes true in the implication. So the P is true, and here think of this one as like if you get an A, then I'll do this one. If you do this, then I'll do that one. So in this one, if you're looking on top, this is true, and if you look at the bottom, false and false becomes true, because here you didn't keep your promise, you didn't get an A in your class. So here even if I give you money here, and if I don't give you money here, I still didn't break any rule or anything. You have to get an A. The condition was you have to get an A, then I'll give you something. But since you didn't get an A, so even if I give you or I don't give you, the both condition becomes true. All right. So how about P and Q? P if and only if Q. The P if true and the Q is true. P if and only if Q is true. If the P is true, if Q is false. P if and only if Q is false, and false. If P is false, then T. Then P if and only if becomes false. And at the last one here we have false and false. P if and only if Q is true. So here P if and only if Q means that P and Q are equivalent. So here we're gonna write here P and Q are equivalent. So here, so P if and only if Q, that it means that P and Q are both equivalent. So the double implication is that true if P and Q are both true. If P and Q are both false, otherwise the double implication is false. So here we have a true and true becomes false, true and false becomes false, false and true becomes false, and false and false become true. So I'll remove this and we go to the next one. The last one is negation, and we have a p and negative p or not p. So the p is true and the not p is false. If the p is false, then the not p is true. So we continue our truth tables. Make a truth table for the statement not p or q. So we're gonna make now, we're gonna try make a truth table for the statement not p or q. Note that this statement is not p or q. The negation belongs to p alone. So here the negation belongs to p alone. Here is the truth table. So we're looking for the truth table, and we're looking for a p and q and not p. Here is not p and not p or q. So here the truth one is the first one is p, not p is a false. And if you look in here, the p here is a true and not p is a false. And if the p is a true, then not p is a false. And if the p is false, then the not p becomes a true. And here this p is false, then the not p becomes true. Okay, so here not p or q. Just now we looking for the or statement here. If you're looking for or, so if the not p is false, then q is true, it becomes a true. So the not p is false and q is false, it becomes false here. So the not p is true and becomes false, but the not p is true. Think of this like this. So we're going to go like this. If the not p is true, this guy here, and q is true, then it becomes a true. So the not p is false, p is false, and the not p is true, and here is false, and it becomes a true. So that's the truth table for not p or q. So here, as we said here, the negation belongs to p alone. Here is the truth table. So we clean this one. We added column for not p to make a filling out of the last column easier. The entries in the not p column were determined by the entries in the p column. Then to fill in the final column, we look only at the column for q and the column for not p, and use the rule for or. So we're looking for the rule for or. Alright, so we wrap up our truth table here, and next video we're gonna talk more about the truth tables. Alright, I'll see you guys in the next video, and bye.